Okay, so now we'll see the working principle of the JK flip-flop. So here that working principle is nothing but we'll implement the truth table. So first of all, here we should mention as the clock will be get it as two cases. So the first case is nothing but whenever the clock is low part and whenever the clock is high part. Okay, so if the clock get it as in low path, so then what happened, the circuit will become as what, so that means what the output we are getting like that way. So if the clock is get it as in high state, so then what happened, what is the output we are collecting from this JK flip flop. Now we'll see that. So first thing is nothing but whenever the clock signal goes to the low position, so that means it connected as 0, so then automatically we can say that the circuit will be in disabled position. So remember one thing, if the flip-flop will be connected as clock, so that means if the clock is in active position, then only the circuit will be activated. If the clock is in inactive position, then the circuit will be in inactive position. Okay, so here also if the clock is in low position, then the automatically, what about the output means here, the output it remains unchanged, that means it's get it as the previous output will be the previous output will be collected as present state output. So that means here whenever the clock is 0, the output qn complement or qn whatever we are taking here, so that will be remains unchanged, that means same as that of the previous output stage and with respect of the values of inputs j and k. So then automatically we can say that the input values will be disabled and the output will be no change we are getting here. Okay, so now coming to the whenever input clock input as high position, so then what about the circuit result means here, what are how many inputs we are having, so first the two inputs we are connecting to the circuit, so then how many possibilities we are getting in the truth table part means, so if you're having two inputs, then automatically we can say that the number of possibilities 2 power n is nothing but we are getting 2 square, so that it will be considered as 4 possibilities we are getting. So that 4 possibilities we may consider as 0 0 0 1 1 0 1 1. So that means whenever the clock is in high position, so the inputs are connected to the gates, so then automatically if you are having two inputs in the circuit diagram, so then only you are getting the possibilities will be 4 possibilities 0 0 0 1 1 0 1 1. Okay, so these are the input possibilities we may get it as whenever the clock is connected to the high pulse. Okay, so for each and every stage the clock will be connected as the high pulse. So now if the clock is high, whenever the inputs will be j and k will be as 0, then what is the result we are getting in output path means, if the both inputs of jk flip-flops are 0, then the output will be, that means the flip-flop will be enters into the hold mode. Okay, so the flip-flop will be enters into the hold mode, and in this mode the output remains same as that of the previous stage. Okay, so that means whatever the previous stage output we are having, that will be equal to the present stage output. Okay, so that means the output remains same as that of the previous stage. So that is nothing but we can say that no change output. So the previous and the present both will be equal here. So there is no change at all we are getting in the present state output. So that we are collecting from the JK input as 0. So now coming to the second case, whenever the clock is high position, so the inputs will be connected J and K as 0 1. So then what is the result means here, the flip-flop will be enters into the reset mode. Okay, so reset mode is nothing but here in this mode the data inputs reset the output Q, thus the outputs are will be represented as 0. Okay, so that means whenever the inputs will be connected as 0 1 path, so then automatically we can say that the output will be reset output, so then it will be represented as in binary, that is 0. Okay, so now coming to the whenever the clock pulse is high, so then the inputs will be connected as 1 and 0, then the output will become as a set position. So in binary we can represent it as set is 1. Okay, so then the flip-flop enters into the set mode. So in this mode the data input sets the output Q, so thus the outputs are will be represented as Q as will be 1 and Q complement will be as 0. Okay, so now coming to the last stage, whenever the clock pulse is high, so then the inputs will be, both the inputs will be as 1, so then automatically the flip-flop enters into the toggle mode. Okay, so whenever the inputs will be connected as 1 1, so then automatically the flip-flop will be enters into the which mode? Toggle mode. So in which toggle mode is nothing but in which output will be considered as complement. Okay, so in which output as considered as the complement case, so then that case we can consider as the toggle case. So complement is nothing but if you're having the input as 0, then it will be converted to the one stage, that is as toggle. Or if you're having logic 1, so that will be converted as logic 0, so that is called as the toggle case. That means complement case we are calling like a toggle case. Okay, so these are the outputs we are collecting from the JK flip-flop. So whenever the clock input is 0, the whole circuit will be disabled position, so then automatically we can say that the previous output will be represented as the present state output. So there is no change at all in the previous stage and present stage. And coming to the next case, whenever the clock is high, so the automatically we can say that we may get the 4 conditions for 2 inputs. So that is nothing but for 0 0 case, the output will be getting to the hold mode, or maybe no change operation we are getting. That means the previous output will be equal to the present stage output. Like this way, if the JK input will be as 0 1 case, then the flip-flop enters into the reset mode. So reset mode is nothing but that is in logic 0 position. So then when the flip-flop will be enters into the 1 0 mode, then automatically the output will be set. So whenever it enters into the toggle case, the flip-flop inputs will be 1 1. That means in that case we are getting the complement output. Okay, so this is the output path of the JK flip-flop. So now we'll see the last flip-flop here, T flip-flop. So that is nothing but this is the logic symbol for T flip-flop. So what is meant by T flip-flop means we are calling like a T flip-flop as toggle flip-flop or complement. Toggle means is nothing but complement. Okay, so this is the logic symbol of toggle flip-flop. Here we are having the single input, that is T, and the 2 outputs we are having Q and Q complement. One is normal and another one is complement. So clock is connected to the each and every flip-flop, that should be normal here. So now coming to the circuit diagram. So this is the circuit diagram for the T flip-flop. So it look like JK flip-flop only, but JK we are considered as the 2 inputs, that is separated by J and K. But coming to T flip-flop, we are having only single input now. So that's why the T only connected to the 2 NAND gates of one of input. Okay, see here, first 2 gates of the one of input should be connected as T only. And another input we should connect it as clock. And what about the third input for this? So the present state whatever we are having, that will be considered as here inputs of the first and second gates. Okay. So now this output we should consider as the complements output of the next case. And here we are having one SR latch. So that is nothing but NAND latch we are connecting. Okay. So now we'll see the working principle here. So this working principle is almost equal to the JK flip-flop, but in the JK we are having 2 inputs, then only we are getting the 4 possibilities. So like hold, reset, set, toggle. But coming to the T flip-flop, it look like a single input. So this flip-flop is almost equal to D flip-flop only. It raises the 2 condition of a single input. So like that here also in T flip-flop we are having the 2 conditions only. Okay. So first, whenever the clock is low. Okay. So that means whenever the clock is low, compulsory it will be in disabled position, right? So that means the circuit is not connected to the activate position. So automatically we can say that the inputs are not connected, that will be also disabled position. Coming to the output case, so what happened means here the circuit will not be connected, so that means it is in disabled position. So automatically we can say that whenever the input as 0, so automatically the previous output whatever we are collecting, the previous output will be equal to the present state output. So the both will be equal. So that means no change operation we are collecting from this first case. Okay, so as this whenever the clock is high position, so that means the clock is in activate position, automatically we can say that the circuit is in activate. So that means inputs are connected to the circuit. So inputs are connected means how many inputs we raised here means depends on that input pin we can raise that condition. So here input pin we have only single, that is T only. So if you're having single pin of input, so then automatically the number of possibilities we are getting 2. So either 0 or 1. So that means 2 conditions here raised. So whenever the clock is high, so the 2 conditions are 0 and 1. Okay. So if the clock pin is high and the input will be 0, then what is the result we are collecting from this means, so whenever the T input is 0, so automatically we can say that the previous output will be represented as present stage output. So that means here we can get the result as again the previous output. So that means the no change operation we are getting. So that is nothing but previous output means if the output may be represented as future state, so then we are getting the present state output. Okay. So now coming to the, whenever the clock signal is high, the input is connected to the 1. So then automatically we can say that the T flip-flop enters into the toggle condition. That means complement condition we raised. Okay. So this is the output of the T flip-flop. So totally we are having 4 types of flip-flops. So one is SR flip-flop. So this output will be no change, reset, set and invalid case. So now coming to the D flip-flop, it will be entered into the only 2 condition because it have only single input. So one is reset condition and another one is set condition. So like this way JK flip-flop also enters into the 4 types of outputs. So because it consists of 2 inputs, then we raised 4 conditions. So hold, reset, set and toggle. But coming to T flip-flop, it will be having only single input, then it will be raised 2 conditions only, no change and toggle condition. So these are the 4 types of flip-flops we are having. So in that one more flip-flop we are raised, that is nothing but master slave JK flip-flop also will be there. So this master slave JK flip-flop is also equal to the normal JK flip-flop, but here what is the difference in between master slave JK and normal JK means here that first circuit, that means master slave JK flip-flop is a combination of 2 SR flip-flops with feedback connection from output to input path. So that means 2 JK flip-flops we are connecting. So the first flip-flop of output should be connected to the next one of input. So that is the difference we are having in master slave JK and normal JK flip-flop. So and in that also we raise the same conditions. The output will be entered into the hold conditions, reset, set and toggle condition. So that means output will be equal for the JK flip-flop and master slave JK, but the circuit connection is different because the master slave JK will be entered into the combination of 2 JK flip-flops and also connected the one feedback connection. That means the first one of the JK flip-flop output is connected to the input of next JK flip-flop circuit. So that is the thing extra we are having in master slave JK flip-flop. Okay, so now we'll see the next concept of flip-flops, that is excitation tables of all flip-flops, whatever we have in the flip-flops classifications, that we have totally 4 types of flip-flops now, SR, JK, D and T. So for all flip-flops we have to find out the excitation tables also. So now we'll see here, excitation table is nothing but whatever the present state output and whatever the future state output we are having. So the relation between present state and future state we have to, that means with the help of present state and future state outputs we'll implement this some flip-flop input values. Okay, with the help of outputs we are finding the input values, that is called as the excitation table. Okay, so characteristic table or truth table is nothing but that is also the relation between the input and output values. Like this way excitation table also it will be explain the relationship between the input and output values. But what is the main difference in between truth table and excitation table means, so here truth table is nothing but with the help of gate, with the help of combinational gates or with the help of circuit diagram will implement the working principle, right? So the working principle will implement the truth table. So but coming to excitation table here, the extension of truth table, that is called as the excitation table. So how to extend it, that excitation table means here, so same thing here, the excitation table is also consist of 4 parts. Okay, that 4 parts we can consider as, one is present state output, and the next state output, that means future state. Okay, Qn and Qn plus 1. Okay, so coming to the flip-flop inputs here, so this we can consider as S or no. So S or how many inputs we are having? S and R 2 inputs. So the 2 inputs you can write it here as this. So that means flip-flop outputs and the flip-flop inputs. Okay, so how to implement the excitation table or how to write the excitation table for each and every flip-flop means here it has some operation, that is, first here whatever the outputs you are having, present state and future state, that you should imagine it as our inputs. Okay, so that means we can consider our outputs as here inputs and inputs as our outputs. Just imagination purpose you can think it. Okay, so then here we have the 2 inputs now. So then Qn and Qn plus 1 as 2 means totally we may get the 4 possibilities. Those are 0 0 0 1 1 0 1 1. Okay, so like this we are getting the totally 4 possibilities for excitation table of input values. So now find the output here. First, the excitation table how to consider means, first we have to comparing the present state and future state values. Okay, so that means here the present state of first condition is 0 and the future state of first condition is 0. So how to compare means if the value will be changed from present state to next state or not. Okay, so we have to compare both the values if the value will be changed or not from one state to another state. Here see it, Qn as 0 and Qn plus 1 as 0 again. So that means here the value is not changed. That means there is no change at all we are getting from the present state to future state. So like that means here we are getting the output is no change. So compared to truth table, so after getting comparison result, so whatever the result we are getting, that will be compared with again truth table. So no change we are getting, right, the first result. That no change operation where we are getting in SR case, that means in input case 0 0 we are getting the no change operation, right. So that 0 0 you can write it as it is here. Okay, so after comparing whatever the result you are collecting, so that result is compared again with the truth table. So that means where in which case you are getting the no change operation, that will be as it is, you can write it the values here. Okay, so now coming to the next condition here. After comparing two cases, then we'll go for the next step. That is the first step, and next step is nothing but whatever the future state output you are having Qn plus 1 value, so that will be raised in truth table. That means if you are having the present case, that means future state value will be 0 no. So that 0 will be where we are getting, that 0 will be in truth table case. So 0 result we are getting in reset path. So reset path of input values will be 0 1. This is the first. Okay, like this way you can compare all the values. So the first one is completed. So in the second case, we have to, first step is comparing the case. 0 to 1 will be changed or not. Okay, so here 0 will be changes to 1. So that means we are getting the complement case here. 0 can changes to the 1. But in truth table, did you get the any complement output? So invalid, set, reset, no change. So we didn't get any complement output. So compulsory we can say that there is no toggle condition here. So leave it that part. Comparison, we didn't get any result in truth table. Coming to the second step, what is the result of Qn plus 1 output? 1. So where we are getting the 1 in truth table condition? So that is nothing but the input values will be 1 0. So that is clear. As it is, you can write it the values and leave it. And now coming to the third condition. In step 1 what we will do? So comparing the values. So step 1 comparing means 1 can changes to 0 here. So it's changed. Changed is nothing but complement case raised. Complement case is it possible in the SR flip-flop of truth table? So there is no case we are getting in the, there is no complement case we are getting in the truth table of SR. So that will also we can leave it. So next one is in step 2. The future state output is 0. So 0 where we are getting in, that means in which case we are getting the reset output. So the 0 output, that means 0 1 case we are getting. So 0 1 as it is, you can write it and leave it. So the next one, in the last case, so comparing the first step. So 1 can changes to 1. So that means here 1 cannot changes to 0 actually. Both values in present state, next state values will be equal. So 1 1. So 1 1 equal is nothing but there is no change here. So no change is nothing but input values will be in SR. What is that? 0 0. Like this way in step 2, what is the output we are collecting? 1. So 1, where we are getting the 1 case here, that is set condition. Set conditions of inputs is 1 0. Okay. So now these are the possibilities we are getting after comparing and after taking the output values. So now finally we have to write the complete excitation table. So rewrite this excitation table as like this: Qn plus 1 SR. So now the final excitation table of SR flip-flop is, so 0 0 conditions as it is you can write it 0 1 1 0 1 1. So why we are again writing this excitation table means in the first case and second case we are raised the 2 possibilities, right? But third and fourth case we have the only 1 possibility. So that 2 conditions we can say that these are the final outputs. But what about the first and last case? It will be raised 2 conditions. Exactly output we don't know. For this case we have to implement again that excitation table. Here see, in both the cases S value will be what? 0. So directly we can say that both the values will be 0 means we can consider as single value. Okay. So now coming to the R value in the first path. So that is nothing but one is 0 and another one is 1. So we don't know the exact value. Here we have the exact value, that is 0. But here we don't know that is exact value, that may be either 0 or either may be 1. Right. So it may be 1 or it may be 0. We don't know exactly. That's why we can mention as like X or cross mark. That means don't care condition you can mention, because we don't know the exact value. That's why we can mention as cross mark. Now coming to the second case, this is having single cases. Directly as it is you can write it 1 and 0, and this will be 0 and 1. And coming to last case, it is also raised 2 conditions 0 1. So like this way. So this is also we don't know the exact value, either 0 or 1. So put it as cross mark. And here 0, both values will be 0 now. So then you can take it as single value 0. So now the SR flip-flop excitation table value is, for 0 0 we can get the 0 don't care, for 0 1 we can get the 1 0, for 1 0 0 1, for 1 1 don't care and 0. So this is the complete excitation table of the SR flip-flop. Okay. So now we'll see the next flip-flop of excitation table. Okay, so this is the truth table of D flip-flop. Already knows from the explanation of D flip-flop. Okay, so whenever the clock is 1, it raises the 2 conditions. One is 0 and another one is 1. So the output will be mentioned as one is 0 for reset and one is for set. That means whatever the input we are giving, the same output we are getting at the present state. That means if you are giving the 0 as input, so that 0 will be present at the output side also. So that means whatever the input we are giving, that will be equal to the output. Okay, so that is the result of D flip-flop. So now we'll find out the excitation table of D flip-flop here. So here also we are taking present state and next state will be the outputs and D will be the input. Okay, so here we have the 2 inputs now, then we are getting the 4 conditions 0 0 0 1 1 0 and 1 1. Totally 4 possibilities we are getting. But here we have only single input, so that is only D. So but if you are finding the excitation table means what are the steps we are moving here. So step 1 is nothing but comparing with present state as next state. Comparing present state with, that means Qn with Qn plus 1. That is the one case. And what is the step 2? Step 2 is nothing but Qn plus 1 as output. Okay, so Qn plus 1 as our output, that will be verified in truth table. These are the 2 conditions we raised in excitation table. But these 2 conditions are applicable for whenever the inputs will be having 2 inputs. But here we'll have the single input now. So then you can follow the only one procedure in these 2 steps, that is only as second step we have to consider. Because comparing Qn with Qn plus 1 is not possible here. Because D flip-flop having only single input, it doesn't have the 2 conditions. It have only single condition, that is either 0 or 1 only. So directly we can go with this step 2. So wherever the Qn plus 1 output you having 0 1 0 1, so this 0 1 0 1 possibility where we are getting in truth table and which case we are getting truth table, that as it is you can take. Okay, so here Qn plus 1 output is what? 0. So in 0 truth table, in which case we are getting, so 0 output, in which case we are getting the input path, again 0 only. Okay, here we have to mention inputs only. So 1 is nothing but Qn plus 1 output is 1. So 1 is set condition. So in truth table set condition, at which possibility, that means what is the input possibility we are getting in output as set, means again input as 1. Okay, so like this way 0 for reset, again 0 we are getting, and for 1 the set condition 1 only we are getting. So this is the excitation table of D flip flop. So now we'll see the next type of flip flop, that is JK. So this is the truth table of the JK flip flop. Already we know the working principle of JK flip flop. So for 0 0 we'll get the output as no change whenever the clock is high. So for 0 1 we'll get the reset, and 1 0 for set, and 1 1 complement we are getting, right? So as we know from the explanation of truth table. So now we'll see the excitation table of JK flip flop here. So already we know Qn and Qn plus 1 consider as the outputs conditions, and JK will be considered as the input conditions. Okay, so now here Qn plus 1 as a 0 0. So what we will do for writing the excitation table, so first we'll have the step 1 condition. If you're having 2 inputs, so compulsory we'll raise the 2 conditions. So first one is comparing, and the second one is directly Qn plus 1 as our output, verifying in truth table. Okay, so first one is comparing. So Qn plus 1 will be changed or not. So in the first state Qn as 0, in this next state Qn plus 1 as again 0. So that means here 0 cannot changes to the 1 here. So 0 as it is present at the 0 only. So that means no change operation we are getting from this 2 outputs. So then now coming to the no change, in which case we are getting in the truth table. So no change operation is nothing but whenever the JK as 0 we are getting the no change operation. So that means it doesn't change. So directly we can say that J and K values will be 0 0. So after comparing, then we'll go with the Qn plus 1 output verified in truth table. So Qn plus 1 output is what? 0. So in which case 0 output we are getting in the JK truth table, that means JK input as 0 1 case. So then only we are getting the output is 0. So as it is you can consider 0 1. So this is the first condition. Now coming to the second one, again we have to consider Qn and Qn plus 1 will be changed or not. So 0 will be changes to the 1. That means here the present state value will be changed to the next state. That will be as 1. So changed condition is nothing but we know that is complement condition. So here 0 will be converted to the 1 means that is a complement condition now. So here also complement condition we are getting. That will be raised in truth table. So in which case in which case complement we are getting in the input path. So 1 1 case. So 1 1 as it is you can write it. Okay, so now taking Qn plus 1 output. So that is 1. So in which case we are getting the 1 as our output. So 1 0 input case set as our output. So 1 0 as one more inputs. Now again we have to comparing the values. So 1 can change or not. So 1 here changes to the 0. So that means we can say that here complement condition raised. Changed, right? So complement condition is raised. So complement condition in which case we are getting JK as 1 1. Next output as 0. So 0 is nothing but, that means we can say that in which case 0 we are getting, as it is we can say that JK as 0 1. So the last condition, so comparing the both the values. So 1 can change it to 0 or not. So it cannot changed. So directly we can say that both the values will be equal. So that means no change operation we are occurring here. So no change means it doesn't change. So in which case we are getting 0 0. So like this the output 1. So 1 in truth table where we are getting the possibility. So 1 0 input possibility we are getting the output as 1. Okay, so from this in each and every case we have the 2 conditions are raised. So for that case again rewrite this excitation table as like this. So for complete output purpose we can rewrite this excitation table. So Qn Qn plus 1 J K. Okay, so now write the inputs possibilities 0 0 0 1 1 0 1 1. Okay, so see here, for 0 0 what is the result we are getting? 2 possibilities we are getting. For J we are getting the 2 possibilities, both will be 0 0, so both the values will be same, so you can consider single value in that. So now coming to the K value, so 0 1 0 1 is nothing but it may be either, or it may be 0, or it may not be 0, right? So it may be 1 or it may not be 1, so we don't know the exact value, right? So that's why we can consider these two values will be as don't care conditions, because we don't know the exactly of it may be 1 or it may be 0. Okay, so like this in second case, for 0 1 this will be 1 and this will be 1 0 again, so that is nothing but both will be different, so you can consider as don't care. So now this one be third case, 1 0, again both will be different values, so we'll take it as don't care, and these two values will be 1 1, so we can say that 1. So and next here 0 1 0 1 means both will be different values, you can consider don't care condition. Here both values will be 0, so you can say that single value, that is 0. So for 0 0 0 don't care, for 0 1 1 don't care, and 1 0 don't care and 1, for 1 1 don't care and 0. Okay, so complete excitation table of JK flip flop is this one. So like this way find out the next flip flop excitation table, that is T flip flop excitation table. Okay, now we'll see that. So this is the truth table of the T flip flop, as you know from the circuit diagram or working principle of T flip flop, we will get this truth table. So that is nothing but whenever the clock is high state, the T inputs as 0 and 1. So for 0 case no change output we are collecting, and for 1 case we are collecting the toggle output. Okay, so now based on this truth table we'll implement the excitation table here. So first, this excitation table considers the two inputs, that is present state output and next state output, and okay, so then we may get it as here T flip flop single input, so you should comparing the two values here, because there is no second step here, because we have only single input.